Question overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Today we're analyzing a crucial GKE security design question. Your company is moving from compute engine to containerized applications on GKE, and security is paramount. The key requirements are crystal clear. We need to isolate the cluster nodes from the internet and block untrusted IP addresses from outside Google Cloud. This is a common enterprise requirement for protecting sensitive workloads. This is a multi-select question, so multiple answers may be correct. Let's examine each option to understand which security measures we should implement for a properly secured GKE cluster. Understanding the security requirements. Before diving into the solutions, let's clarify what we're protecting against. When we talk about isolating nodes from the internet, we mean preventing direct internet access to and from the cluster nodes themselves. This doesn't mean your applications can't serve traffic. They still can through load balancers and ingress controllers. What we're preventing is direct access to the nodes, which could be exploited by attackers. The diagram shows the difference between a standard GKE cluster, where nodes have public IPs, versus what we need to build, a secure, isolated environment. Notice how in the secure design, there's no direct path from the internet to the nodes. This type of architecture is essential for compliance requirements like PCI DSS, HIPAA, or simply following security best practices. Option 1. IAM configuration. Let's examine, configure IAM to prevent access from untrusted actors. While IAM is absolutely critical for GKE security, it's important to understand what it does and doesn't do. IAM controls who can perform actions on your GKE resources, like who can create pods, view secrets, or delete services. It's about authentication and authorization within the Google Cloud Control Plane and Kubernetes API. However, IAM doesn't control network-level access to your nodes. An attacker trying to SSH directly to a node or scanning for open ports isn't stopped by IAM. They're stopped by network controls. Think of IAM as your security guard checking badges at the building entrance, while network isolation is like having a moat around your castle. Both are important, but they serve different purposes. For our specific requirement of network isolation, IAM alone isn't sufficient. Option 2. Private cluster configuration. Now we're talking. Configure the cluster as a private cluster is exactly what we need for node isolation. This is GKE's built-in feature specifically designed for this use case. In a private cluster, nodes only get internal IP addresses, no public IPs at all. This means they're completely unreachable from the internet by default. It's like having your servers in a locked room with no windows to the outside world. The beauty of private clusters is that while your nodes are isolated, your applications can still serve public traffic through Google Cloud load balancers. The load balancers act as a secure proxy between the internet and your applications. The configuration shown demonstrates how to create a private cluster with the key flags that enable this isolation. This is definitely part of our solution. Option 3. Hybrid connectivity. Configure a hybrid connectivity using either the Cloud VPN or Cloud Interconnect. This option is about connecting your GKE cluster to on-premises resources, not about blocking internet access. Cloud VPN and Interconnect are fantastic for creating secure tunnels between your GKE cluster and your data center. They're essential if you need your containerized apps to communicate with on-premises databases or legacy systems. However, these technologies don't inherently block untrusted IPs or isolate nodes from the internet. In fact, you typically use these alongside private clusters, not instead of them. Think of hybrid connectivity as building a secure highway between your cloud and on-premises environments. It's valuable for many architectures, but it doesn't address our specific security requirements about internet isolation. Option 4. Workload identity. Workload identity is a powerful GKE feature, but let's understand what it actually does. It allows your pods to authenticate as Google service accounts without storing service account keys in your cluster. This is fantastic for security. No more secret keys that could be compromised. Your applications can securely access Google Cloud services like cloud storage or BigQuery using proper identity-based authentication. However, workload identity is about application identity and authentication to Google Cloud services. It doesn't control network access to your nodes or block IP addresses. An attacker trying to reach your nodes over the network isn't affected by workload identity. While workload identity is a security best practice I'd recommend for any GKE cluster, it doesn't fulfill our specific requirement of network isolation and IP blocking. Option 5. Authorized networks. Here's our second correct answer. Configure the cluster to use authorized networks, directly addresses the requirement to block untrusted IP addresses. Authorized networks, formerly called master authorized networks, allow you to specify exactly which IP ranges can access your cluster's API server. It's like having an allow list at your front door. If you're not on the list, you can't even knock. This feature is perfect for scenarios where you want to ensure only your corporate network, specific jump hosts, or Cloud Shell can manage your cluster. Any IP address not in your authorized list is completely blocked from accessing the Kubernetes API. Combined with private clusters, authorized networks create a powerful security barrier. Private clusters protect your nodes, while authorized networks protect your control plane. Together, they provide comprehensive network isolation. Complete security architecture. Let's see how private clusters and authorized networks work together to create a secure GKE environment. This architecture implements defense in depth, multiple layers of security working in concert. Notice in the diagram how we have no direct paths from the internet to either the nodes or the control plane. The only access points are through controlled channels, load balancers for application traffic, and authorized IPs for cluster management. This setup satisfies both requirements. Nodes are isolated from the internet via private cluster configuration, and untrusted IPs are blocked via authorized networks. Your applications remain accessible to users through load balancers, but the infrastructure is protected. This is the architecture I've implemented for many enterprise clients, and it provides an excellent balance of security and functionality. Implementation Guide. Let me walk you through the exact commands to implement this secure architecture. These commands create a production-ready private GKE cluster with authorized networks. First, we create the cluster with private nodes and private endpoint options. The Enable Private Nodes flag ensures nodes don't get public IPs, while Enable Private Endpoint makes even the API server accessible only from internal networks. The Master IPv4 CIDR defines the IP range for your control plane. Choose something that doesn't conflict with your VPC. The Enable IP alias flag is required for private clusters and enables VPC native networking. For authorized networks, we specify which IPs can access the API server. In production, you typically include your corporate network ranges, CD systems, and perhaps Cloud Shell. The Enable Master Authorized Networks flag activates this feature. These commands give you a fully locked down cluster that meets enterprise security requirements. Summary and best practices. Let's wrap up with the key takeaways. For isolating GKE nodes from the internet and blocking untrusted IPs, the correct solutions are private clusters and authorized networks. Private clusters ensure your nodes have no public IP addresses, making them unreachable from the internet. Authorized networks create an IP allow list for API server access, blocking any unauthorized access attempts. While IAM, workload identity, and hybrid connectivity are all important security features, they serve different purposes and don't directly address network isolation requirements. Remember, security is about layers. In production, you'd implement private clusters and authorized networks as your foundation, then add IAM policies, workload identity, network policies, and other security measures. This creates a robust, defense in-depth architecture that protects your containerized workloads from multiple attack vectors. Thank you for your attendance. Please subscribe to the channel if you haven't done so yet.